Okay, in this problem we want to find the antiderivative of 3 over x times the natural log of 7x. And it says assume u is greater than 0 when natural log of u appears. What that is implying is that u is positive, whatever's inside the natural log is positive, and therefore you don't need the absolute value bars when you antidifferentiate. So that's a detail for the end of the problem. Okay, so the first thing is this is too complex to antidifferentiate with standard rules. So we're going to have to try substitution. The trick is finding u, okay? And in figuring out what u should be, it's probably wise to review derivative rules real quick. The thing to remember here is that the derivative of the natural log of x is 1 over x. So we want to use that fact when trying to figure out what u is, because you want to choose u so that both u and its derivative both appear here in the integrand. Well, since we have an x in the denominator, that's kind of like this 1 over x, I would go for u equaling natural log of 7x, and let's give that a try and see what happens. Let's try u equals the natural log of 7x. I like to add parentheses there. So then when we differentiate this equation, we get du dx equals, okay, we have a natural log of a function. So by chain rule, it's going to be 1 over that inside function times the derivative of that function. So we're going to have 1 over 7x times 7. And your 7's cancel, so that just is 1 over x. Then we multiply the dx to the other side, so we get du equals 1 over x times dx. Now let's go rewrite this antiderivative. The 3 really has no bearing on the problem, so let's go ahead and pull that out. And then let's split up the denominator, or split up the fraction into a product of 2 fractions. And you don't necessarily have to write it this way, but I think it kind of helps just to see all the pieces. We're going to go down here, right, because the 1 over x is a little bit more apparent, and then it's clear how this is separate from the 1 over u. Right, I'm just unmultiplying these 2 fractions, right? Multiply together, you just multiply the denominators. And also, let's go ahead and do this. Let's reverse these 2 terms, because order of multiplication doesn't matter. Just to, again, make it a little bit more clear. So let's write it as 1 over the natural log of 7x times 1 over x dx. Okay, now we can switch it to an integral in terms of u. So the 1 over x dx is all equal to du. So that part all becomes du. And then u is defined as the natural log of 7x. So just this denominator right there, the denominator only, becomes u. So if we rewrite this now in terms of u, we have 3 times the antiderivative of 1 over u du. Okay, so using antiderivative rules, that's the natural log of, I would put absolute value of u, but it says u is positive all up here, so we can just leave off the absolute value bars. And then we go all the way back to x's. U is defined as the natural log of 7x. So this one's kind of strange. We end up with the natural log of 7x. Let's go give that a try. 3 times the natural log of the natural log of 7x. Plus b.